In this lecture, we'll either speed up or slow down our level depending on if we eat an apple or get hit by an obstacle. Now that we have the basic structure for our level set up for both hitting obstacles or eating our power-up apple, we can actually implement our level speeding up or slowing down back in our level generator class. Let's go ahead and open that up in VS Code. I believe it's in our procedural generation folder. We can see here in our level generator class, we actually have this move speed variable on which we're moving our entire level. Well, we can actually just speed up or slow down our level directly here in our level generator class, depending on which we need with a public function. So right here below our update function, let's create a public method so we can do that. Let's create a public void method that I'll just call change chunk move speed. And because inside of this method, we want to sometimes speed our level up and sometimes we want to slow it down, well, we can actually just pass through a float parameter that I'll call speed amount. And depending on whatever float we pass through, whether it's a negative or a positive value, we can just adjust things appropriately. So we can set our move speed variable up top equal to move speed plus our speed amount. So the shorthand for that is plus equal speed amount. So if we add a positive value, this will add a positive value. And if we pass through a negative value, this will actually decrease our move speed variable. I do think it would make sense if we had some sort of minimum move speed. However, we don't ever want our player actually abrupting to a complete halt. So right below our move speed variable up top, let's just duplicate that line with Control-Shift-D, and I'll create a new variable called min move speed. And I think setting that to something like 2 would make sense. So let's go ahead and set that to 2f. That way down below here, we can actually just go ahead and create a basic if block and say if move speed is less than our min move speed, well, then just set move speed equal to our min move speed. And that should be really all we need. We can actually now use this public function in both our apple and our player collision class. Let's go ahead and do that in our player collision handler first. The shorthand to open up that script in VS Code is actually searching for it by hitting Control-P. That'll open up this little search file bar up top, and then we can just search for player collision handler class and just open that up manually. Right here in our onCollisionEnter method, we just want to call that public function. So we're going to first need a reference to our level generator. Well, we only have one player, so let's just actually go ahead and keep things simple and call that in start. Let's create a reference to level generator. We'll just call that level generator with a lowercase l. Create a void start, and inside start, just go ahead and look for the level generator. We're only ever doing it once at the very beginning of our game. That should be just fine by me. So level generator is equal to find first object by type. We're looking for our level generator and open and close parentheses to call that method. Now that we have that reference right here in our onCollisionEnter method, we can just go in to level generator dot, what did we call it? Change chunk move speed, and then just pass through some sort of float. Well, I think that would also make sense to create that as a serialized field up top, just so we can actually balance our game further if needed. Let's create a serialized field as a float, and we can just give this a nice explicit name, something like adjust change move speed amount. Whew, bit of a mouthful. I think setting this to something like -2 would make sense. In other words, we're slowing our game down, so a -2 value. Now we can just use this variable down below and pass it through as an argument in our change chunk move speed method. Nice, let's actually go try that out back in Unity. All right, let's go ahead and hit play and see if that works. When we hit our fence, we should just slow down by about -2. Yeah, there you go. You can actually notice it. Let's see if we can hit an obstacle and do the same. I'm going to actually dodge this fence here just to make sure it works. And let's see if I can hit this. There we go. We trip one more time and we're slowing down. Once we get to a move amount of 2, which I think we're at now, there you go. We're no longer slowing down anymore, and we're at that min move speed amount. Nice, looking good so far. Let's go ahead and do the same for the apple, except the opposite and speed up, which will introduce you to this lecture's challenge. Increase the speed of our level by 3f when we pick up an apple in our apple script in our onPickup method using our change chunk move speed public method over back in our level generator class. So more or less the same thing, but just rigging it up with a +3 value instead of a -2 value. Go ahead and pause the video, give it an honest effort, and I'll see you back here shortly. Welcome back. Let's go ahead and open up our apple class. So pickups and apple. We just want to rig up more or less the exact same thing. So I'm going to create another serialized float. I think it would make sense to call it the exact same thing. We called it in our player collision handler class. So I'm just going to come in here, copy this entire line, head into our apple class, paste this here, and then just change this value to a +3. Inside of our onPickup method, instead of this debug.log, we just want to go into our level generator, for which we need to create a reference. So for now, let's just actually go ahead and do the same thing and just grab it on start. So level generator reference, and here we go here. So right here on start, so void start, and set level generator equal to find first object by type level generator. Great. However, in this case, unlike our player where we just have the one player at the beginning of the game calling on start, we actually have, a halfway decent reasonable amount of apples spawning in or instantiating through our game, which, a bit of a code smell here. I will say there are some more eloquent solutions to kind of flip the dependency around, but most of the solutions that I can think of, like dependency injection, subscribing to actions, or a service locator, all of those fancy schmancy things that I just brought up, just tuck them away for another day. They're all a bit out of scope for what we'd like to learn for now. But for now, let's just be satisfied with using find first object by type, calling it in start. Now that we have that reference, let's just go into level generator, dot change chunk move speed, and then just pass through this adjust change move speed amount variable. Great, let's go try that out back in Unity. Blow up our game view, and let's see what that looks like. I'm gonna actually try our best to just dodge fences. There we go, we're speeding up. Well, let's just hit one fence to slow back down. Yep, even though you can barely see it, we probably need a little bit more visual feedback. And I'm just actually going to show you the little bit of a bug that we've kind of created. If we start to gather too many apples, or really even just when we hit a fence and go the opposite direction, our physics of our objects aren't really playing too nicely. It's almost like we entered some sort of Twilight Zone, and the physics of our obstacles flying through our scene aren't really cooperating very nicely. We probably want to also set up some sort of max move speed as well. But for now, let's go ahead and get our obstacles behaving the way that you would imagine instead of kind of going the opposite direction. Well, the reason that is because in our edit and project settings, in our physics settings below our project settings, we just have our gravity set to negative 9.81 on our Z value, which if we're actually moving a reasonable speed, seems to work just fine. Well, there's actually quite a simple solution for this, which is just modifying this physics Z value equal to how much we're either speeding up or slowing down. And that's as easy as just writing one line of code in our change chunk move speed method. Let's go hop back into our level generator class to change that. Here in our level generator class, in our change chunk move speed method, we just need to write one line of code to manually modify the physics amount on our Z axis. We can manually change those physics settings by actually just typing physics.gravity and modifying that vector 3 value on both the x, y, and z. So let's actually just create a new vector 3. And we know we don't want to modify our x and our y value, just our z value. So you can actually just go into physics.gravity.x value. Great, we want that to stay the same, and the same for the y. So physics.gravity.y. Yep, same value. We don't want that to change, but we do want to modify the z value. So we want to go into our physics.gravity.z minus the speed amount, not plus the amount. If we're passing through a positive value, then we actually want to subtract our speed amount. And if we're passing through a negative value, we want to actually add to our physics.gravity.z value. Nice, now that we're modifying our physics every single time we either slow down or speed up, let's hop back into Unity and try that one more time. I'm going to pull up my physics settings, drag it off my monitor just a little bit, just so we can actually see this Z value being modified when we either slow down or speed up. So let's go ahead and hit a fence. Yep, we're modifying our Z property. And when we hit an apple, yep, we're increasing it. Or basically, I suppose I should say, decreasing it more than what it was. Silly me. All right, and you know what? I think that actually looks pretty good. Even if we start reaching unattainable speeds, that's probably a little bit imbalanced, and we start moving incredibly quickly, our objects are actually still falling through space as you would think that it would behave with more or less normal physics gravity settings. Now that we have the basics of that set up, I do think we could use a little bit more visual feedback to the player to really sell the idea that we're either speeding up or slowing down. We'll tackle that in the next lecture. I'll see you there.